Hey, doing a quick video on the area of an oblique triangle today. So check it out. We have right here, let's figure out kind of where did this idea of the oblique area come from. We're used to finding areas of regular triangles where it's maybe a right triangle or something. We find a height and then we have a base. And so the normal area is equal to 1/2 the base times the height. But we need some different ways to solve for the area of a triangle. So what we're going to do is we're going to trigify it. We're going to put some trigonometry into our area function and see if we can find the area. So if we let A equal the hypotenuse, here's our angle theta, all of our base B, and H is the height of the triangle. We labeled H the height instead of the hypotenuse. Then what we have with our angle is H, the height, over our A, our hypotenuse, because B goes the whole distance. So we can't use really a cosine option because this B is the full distance instead of just that little short piece right there, okay? So if we let A equal the hypotenuse, and if sine of theta, the sine of theta is the hypotenuse, or the opposite over the hypotenuse, or H over A, then we can algebraically manipulate this to say that if we multiply each side by A, then A sine theta is equal to the H. Well, now, what we can do is we can substitute that information back into our normal triangle area, and we'll say that the area with the trig information is 1/2 the base times A sine theta, or area is equal to 1/2 A B sine theta. So what must we have when we do that? Well, you'll notice that we have A and we have B. So we have two sides that have within it the angle. Okay? So two sides and the inclusive angle. We must have that. So star must have two sides and an inclusive angle. If we don't have that, then we have to do some more law of sines tricks to get that done. So let's look at an example. We have a triangle here. We've got 13 and 14 as two side lengths. The inclusive angle is 66 degrees. So now we'll take the area of 1/2 times 13 times 14 times the sine of 66 degrees. And if we put that into our calculator, we will get the area is equal to 83.13 units squared. Could be feet, could be centimeters, whatever the problem calls for. All right, let's look at another example here where we've got another triangle here. It's oblique because it's not a regular shaped triangle. It's not a right triangle. And all the different side measures are different. So what they gave us here was side across from C is 5.3. The side across from A, we don't know. It's little a. And the side across from B, we don't know. We don't even know the angle measure of B. And we do know 109. So do we have a situation here where we have two sides and an inclusive angle? No, we don't. So we have to use some law of sines to work on that. Now, what I'm noticing is that if I have enough information to get A right now, and if I get A, and then I can find B, well, then I can do it because I have this side, and I have the A side, and then I'll have the inclusive angle. And that inclusive angle is pretty easy to find because we have 40 and 109, so we can pretty much tell what that will be if we use 180 minus. So what I did was we first find A. A over the sine of 40 is equal to 5.3 over the sine of 109. Then, cross multiplying, we get A is equal to 4.3 times the sine of 40 divided by sine of 109. And so A is 3.6. So I'm going to go ahead and label that now, 3.6. All right, now we have our two sides, our two side lengths, and now what we got to do is find that angle measure B. There's no sense really in finding the value of the distance of b, the little b. If I was asked to solve the whole triangle, then I would do that. But all I'm asked to do is find the area, which it says right here, find the area. Okay? See, I told you it said that. Okay. So now, and now I want to do is, what is angle B? Well, solve for letter B, angle B, and that's 180. All triangles add up to 180 degrees. Minus 40 degrees, right? Minus 40, minus 109, and that gives me an angle measure of 31. So right now I can say that this angle there is 31 degrees. Okay. Now I have an angle that is inclusive of the two sides, and now I can go ahead and use my area equation. Area is equal to 1/2 times 5.3, which is one of the sides, times the other side, 3.6, times the sine of the inclusive angle, and when you put that in your calculator, the area is 4.913 units. All right, hope that helped. Enjoy. This has been another math-tastic video by Mr. Dykstra, and that's the area of the oblique triangle. Thank you. Enjoy.